Hello everyone, welcome to all in this lecture. In this lecture, I am going to discuss center of gravity of a section with cutout holes. It means when you will consider a section, so we'll find some portion are missing, some part are missing. So if some part are missing from a whole section, then how you will calculate center of gravity for the remaining section? Okay. So if you remember, in the first class, I have discussed how we got the formula to calculate the center of gravity for the composite section. Means we have divided a composite section or a section in a number of segment in a such a way that for each segment, center of gravity should be known. Okay. So I'm using the same concept here. This is the y-axis. This is the x-axis. And suppose this is the figure that we have, and this is the solid figure, okay? A plane figure, we can say. This is a plane figure. In this plane figure, this portion are missing, right? This portion are missing. And this missing portion, center of gravity is x3 and y3. Okay. And suppose for this total figure that we have, their centroid, suppose here, for this one, total figure. So there, I'm writing this, suppose this is the x2, we can write for this missing figure, and this is x1 I'm writing. First, we have to understand what is the x1 and x2. See, whatever the figure is given, so this is the total figure, total area. Okay, and I'm considering this total area is A1. So in this total area, some portion, and I'm giving some portion like area is A3, A2. Okay, this is A2. So in this total area A1, A2 area are missing. Some hole are there. Okay, so and this for this missing area, their center of gravity at a say, x2 distance from the y-axis and y2 distance from the x-axis. Are you getting my point? So we have to calculate whatever the remaining area. So remaining area we can write. Remaining area, total area we have A1 and missing part is A2. Okay, so remaining area we have A1 minus A2. So we have to calculate for this area A1 minus A2 what will be the center of gravity. So we have to calculate this one. So now first calculate what will be the moment of area for these two area, like total area and missing part. Okay, so I'm writing, and just let's assume for remaining area their centroid is x bar and y bar for this area, for remaining area, right? So now we can calculate moment of area from O, from O point, moment of area from O point of remaining area. So what we can write? What moment of area means whatever the area we have and their centroid distance from the y-axis. So I'm calculating from the y. So we can write remaining area we have A1 minus A2, and what is the distance from the y-axis? We have taken x bar. We have taken the assumption that is x bar, right? So we can write x bar. This is the first equation. Now let's calculate moment of area from O by considering considering total area and meshing area, we can say. What we can write? Tell me. So see, we have to write what with the moment of area will come from this point. So what I will do, if I'm writing like this, A1 into X1, by considering A1 is the total area. So by considering the total area, we can write for the total area A1 into X1. But see, that is not correct. I'm writing this. So now we have to calculate the moment of area for the remaining portion. So in the remaining portion, A1 total is not, total A1 will not count. So what we can do? So A1 into X1, it means we have taken all area. So we have to deduct moment. What moment we have to deduct? That moment will come by the missing area. Are you getting my point? Because the missing area already we have counted here. Okay. So we have to deduct. So how we can deduct? X2, what is the missing area? A2. What is the distance of centroid from the y-axis? That is X2. Are you getting my point? Now, so both equation 1 and 2 are talking about this remaining area. So we have calculated this moment of area in the second equation also for the remaining area, or in the first equation also we have talking about the moment of area for the remaining area. Are you getting one? So we can equate both the equation. So by equating both equation 1 and 2, what we can get? A1 minus A2 into X bar is equal to A1 X1 minus A2 X2. From here we can write X bar is equal to A1 X1 A2 X2 divided by A1 minus A2. So this is the general expression to calculate center of gravity of section with a cutout holes. Similarly, if you want to derive, you can derive, but similarly you can write for y bar also. Similarly, you can write for y bar also. Similarly, we can write for y bar, that is A1 y1 minus A2 y2 divided by A1 minus A2. Right. See, so by calculating X bar and Y bar for the center of gravity for the cutout holes, so what we have to do, we will take A1 as a total area, and then we will take A2, then we will see what area or what volume we are deducting. Are you getting my point? Right? So that we have to see. In terms of, this is a formula for the plane figures. If you will calculate for a solid body, we can write A1, we can write V1 X1 minus V2 X2 divided by V1 minus V2. Area will convert in terms of volume. If you are working for the line, so area will convert into the line. So for the line, we can write X bar, this for the solid body. For line, we can write X1, L1, X1 minus L2, X2 divided by L1 minus L2. So this is for line. This formula for the line. Now you can see I'm going to calculate for this one. So see, in this case, this is the circle. Okay, so you can see the whole circle. We know the circle, for the circle center of gravity it would be the center. So centroid will be here at the center for circle. Okay, but now see this portion have deducted. This portion are missing area, we can say. We can say cutout holes. Okay, so now for the circle we know the centroid, but now this portion has deducted. This portion has deducted. So what we can, how we can calculate for this deducted remaining portion? So whatever the given in this figure, we have to calculate center of gravity for that. So what we can do? So I am assuming the total area, that is circle, is A1. Circle is A1. For the circle, we know the centroid. Now I'm assuming this remaining portion, missing portion is A2. Are you getting a point? So what I will do, if by the taking the moments for the total, then we will deduct the moment from this portion. Finally, we will get this value. This finally we will get moment of inertia for this portion. For this portion, right? So first I will consider total circle, total area, and then we will deduct this missing portion, that is A2. So from this figure, we can write radius is given for the circle. So A1 we can write by R square. I am going to calculate the moment of centroid from the we can calculate. So I'm going to calculate like this. See, this line is x1. So I'm going to calculate x bar. So due to the symmetry, we can say here by taking the y on x-axis. Here in this case, we can say due to symmetry that y bar will be 0. So we have to calculate x bar, right? We have to calculate x bar. So A1 will be the area of circle, that is pi r square. What will be the x1? For circle, we can write centroid will be here for the circle, for the center here. Okay, so this distance is r. So we can write x1 is r. Now come to the missing portion, that is holes. The area of holes, that is we have given a name A2. So A2 will be, see, this is the square. This is the square, and their diagonal is R1. Here R is the diagonal. So this one is also R. So we know the area for the square. This is the half of multiplication of their diagonal. So half of multiplication of their diagonal, that is R. Other diagonal is also R. So we can write R square by 2. 0.5. So we can write 0.5 R square. So now we have the A2. Now we can calculate x2. What is the x2? X2 is the distance of centroid of missing area from the y-axis. So for the square, center will be here. Center will be here. So now we can calculate this one is x2. So what we can write x2? See, up to here, this is R1. Now, this value total is R. So centroid will be lie here for the missing area. So this will be R by 2. So up to here, R, and here to here, that is R by 2. So we can write R plus R by 2 will come 1.5 R. I'll get you a point. Okay. So now we have the A1, X1, that is we have considered this one for total circle, total figure, that is circle. Now X2, A2 is for the missing area. So now we can apply the formula, that is X bar is equal to A1 X1 minus A2 X2 divided by A1 minus A2. Now just put the value and get the result. So A1 we have pi R square into what is the X1? X1 we have R minus A2 0.5 R square into X2, that is 1.5 R divided by A1 pi R square minus A2, that is 0.5 R square. So we can take R square, R cube here, we can take the common. So by taking the R cube common, it will come pi minus 0.5 into 1.5, it will come 0.75 niche we can in the denominator we can take the r square is common, so it will come pi minus 0.5. So finally it will come r into pi minus 0.75 divided by pi. By solving you can get, I have already solved, so you can, I'm writing directly. So by solving you can get 0.9, sorry, 0.905 r, 0.905 r. Are you getting a point? So you have to consider total figure, then we can deduct the, we have to find the missing figure on holes. So you have to calculate the area for the holes and for the total figure. Then you have to find out the centroid, the x1 and x2. And then we can apply the formula and you can get the centroid for the remaining figure. Now come to this question. So in this question, you can see a circle, a small circle deducted from the larger circle. Okay, so we can consider this larger circle, that is A1, and this small circle, that is missing area, area of missing, that is we have written A2. So what I am going to do, I am going to this, suppose this one is A2, then I am going to deduct this a small area, that is A2. So it will come like this. So we will get centroid. So I'm going to calculate x bar for this one, for the remaining. So what we will do, we will calculate, we will take the first, the big circle, or larger circle, and we deduct a small circle. Okay. So now, from here we can write A1. What is the A1? Area of the circle, larger circle, and the diameter is 100 mm. So we can write pi by 4 into 100 square. So what it will come? It will come 2500 pi. Right? Okay. Now, x1. Let's assume first the axis. So I'm taking again, this is y-axis and this is x-axis. So due to symmetry, we can write here y bar will be 0. So we are going to calculate x bar. Now, what will be the x1? So for the circle, center will be at this. Centroid will be at the center. Okay. So x1 we can write here. That will be the area. Radius, sorry. That will be the radius. So radius is diameter by 2 means 50 mm. Right? Okay. Now, A2. A2 is the area of hole or missing area, we can say. So that is a smaller, the diameter is 50 mm. So we can calculate area pi by 4 into d square. So d we have 50. You will get 625 pi. Now, x2. What is x2? x2 is the distance of centroid for the missing area from the y-axis. So centroid for this missing area would be here. So we have to calculate distance, that is x2. So up to here you will get r, that is 50 mm plus this one. So this one diameter, area of the small circle. So area of a radius of a small circle. So radius of a small circle will come diameter by 2. So it will come 50 by 2. So total we can write here that is 50 plus 50 by 2. So it will come 75 mm. Right? So now we have the x1, a1, x2, a2. So now we can apply the formula and we can get the x bar. X bar we have a1 into x1 minus a2 into x2 divided by a1 minus a2. So 2500, let's put the whole value. X1 we have 50, a2 we have 625 pi, into x2 we have 75, divided by a1 we have 2500 pi minus a2 that we have 625 pi. Now you can calculate this value. So I have calculated, so I'm writing directly. So we'll get this value 41.67 mm. Okay, so you have to see total area and then you have to see the what will be the missing area, what will the area of hole. Are you getting my point? So then you can apply this formula. Okay, then you can get the X bar. Now see this question. So in this question you can see that a semicircle is there, and again a semicircle with a smaller diameter, which are deducted from the larger diameter. Okay, so again I am considering this semicircle with the larger diameter, that is A1, and semicircle with the a smaller diameter, that is A2. Right. So what I'm going to do, I'm going to deduct this one, that is A1. I will deduct smaller diameter. This diameter is 200 mm. Diameter for a smaller semicircle is 160 mm. So now I'm considering this one is A2. So by deducting, you will get this figure. I'll get a point. So we have to calculate X bar or whatever the Y bar for this figure, right? So let's assume the some axis. So I'm taking at the middle point. This is the Y axis, X axis. So due to symmetry, we can say here the X bar for the missing area will be for this figure will be 0. So now we have to calculate Y bar. We have to calculate the Y bar. So how we can calculate? So let's calculate the A1, A2. So A1 is the total area of semicircle with a larger diameter. So we can write pi by 4 into d square divided by 2, area of semicircle. So pi by 8 into, what is the d? 200. What we can get? So we can get A1, that is 5000 pi. Now, what will be the X1? So for this X1, we know for the semicircle, what is the X1? No, not X1, Y1. So Y1, what is the formula for the semicircle? That is 4r by 3 pi. So we can write 4. What is the r? R, diameter divided by 2. So diameter we have 200 divided by 2, 4r divided by 3 pi. So you can get Y1 42.44 mm. Now come to the area of deducted portion. So that is A2, which is the semicircle with a smaller diameter. So we can write pi by 8 into 160 square. What we can get? I have calculated, so I'm writing directly. 3200 pi. And what will be the Y2? See, Y2 x is same, so Y2 will be the 4r by 3 pi. But in this case, a radius is small. So 4r, that is 160 divided by 2, diameter by 2 divided by 3 pi. So by solving, we will get this value 39.95 mm. Don't write this value. First to calculate by using your calculator, then you see we are getting the same value or not. Okay. Now we have the A1, X1, Y1, A2, Y2. So we can calculate Y bar, that is A1, Y1 minus A2, Y2 divided by A1 minus A2. So A1 we have 5000 pi into Y1, 42.44 minus A2, 3200 pi into Y2, that is 33.95 divided by A1 minus A2, that is 5000 1000 pi minus A1, that is 3200 pi. So by solving, you will get, I have calculated, so I'm writing directly 57.533 mm. Right? Okay. So you have to see the total area, you have to calculate the area for the holes or deducted portion. Then you can apply this formula and then you can calculate the X bar and Y bar. I get your point. Okay, good. Now again we are going to calculate center of gravity for the solid bodies. So this is the plane figure it look like, but you have to understand this is the cylinder. This is the right circular cylinder. The top portion is hemisphere. So what is there that one hemisphere is deducted from the top portion from the cylinder. Are you getting a point? So in this case, what we can do? So for the cylinder, I'm taking A1 total volume, not A1. In this case, it will come V1 volume. Now we are going to work for the solid body. So V1, V2. And this hemisphere, I'm writing V2. So in this case, what I'm going to do, I have taken a total, this is after V1, that is cylinder. I'm going to deduct a hemisphere. This is the hemisphere. So I'm going to take this. So finally, you will get this value. You will get X bar or Y bar, whatever, X bar and Y bar for this remaining portion. So that we have to calculate, right? So all the data we have, so we can calculate the V1, V2. So first assume some axis. So I'm taking this center portion, the Y axis, this base, and X axis. So due to symmetric about the Y axis, we can say X bar for the remaining figure will be 0. So we have to calculate Y bar. So first calculate V1. What is V1? Volume of right circular cylinder. So that we can write pi by 4 into d square. What is the diameter of this cylinder? That is 80 mm. So 80 into 80 square into what is the height? So height is 160. So you can calculate, you will get the value. I have calculated, so I'm writing directly. So we'll get this value, that is V1. And then calculate what will be this X1 here. So X1 will be the 0, but now we are going to calculate Y1. So what will be the Y1? So for the cylinder, this centroid is a distance of h by 2. So for the cylinder I'm talking about, so this will be the at h by 2 distance. So h by 2 means 160 divided by 2, 80 mm. For the cylinder I'm talking about. So 160 divided by 2, that is 80 mm. Now come to the hemisphere part. So V2, what is the formula for hemisphere? So 2 pi by 3 into r cube. What is the radius of this hemisphere? So diameter is 40. So radius will be half of diameter, that is 40. 40 cube. So we'll get some value. And what will be the Y2? See, for this value, we know that for the hemisphere, suppose hemisphere will be somewhere here. G. So we know the distance from the base from this one, that is 3r by 8, right? So we have to calculate. So distance of this from the base, from the x-axis, that is y2. So y2 we can write total, that is total 160 minus this distance 3r by 8. So what is the radius of a hemisphere? That is 40. So we can write 40 divided by 8. So you can get 145 mm. So now we have the V1, V2, Y1, Y2. So now we can apply the formula to calculate y bar, that is V1 into y1 minus V2 into y2 divided by V1 minus V2. So all the data we have, we just use and we can calculate the value for the y bar. By calculation, you will get the V1, that is, I'm writing here. So V1 you will get 256,000 pi, 256,000 pi, and V2 you will get, you can calculate also, V2 will get 134,041.28 mm3. This is the volume. Here also mm3. Now, so you can put the value of V1, Y1, V2, Y2. So you will get the Y bar. So 256,000 pi into, what is Y1? 80 minus V2, 134,041.28 into, what is Y2? That is 145 divided by V1 minus V2. 156,000, sorry, 156,000 pi minus V2, that is 134,041.28. So by solving, you will get the value, that is 67 mm. You can calculate also. So in this case, we have to apply the formula. In the case of solid bodies, area will convert in terms of volume. In terms of line, area will convert in terms of line. Okay, L1, L2, L3, L4, L5, whatever. Okay, I am writing, I will show one question here. So here we have need to deduct only one area. In coming question, you will see we are deducting 2-3 area. So that case you can see also how we are going to calculate the center of gravity. See, you can see this is a plane figure, but you can see this portion is right circular cylinder. Okay, and their portion right circular cone is have deducted from this right circular cylinder at the base, right? Okay, so what we will do in this case, I'm going to assume this one is A1. Sorry, this is the volume, so V1. Right circular cylinder and deducted portion, I'm going to assume V2. So what is the concept behind this? So I'm going to, so this is the V1. I'm going to deduct a right circular portion, that is V2. So what finally will get, you will get this. Okay, we will get centroid of this area. If consider total, then we are going to deduct this V2. So we will get the centroid for this remaining portion, X bar and Y bar. So now first let's assume this axis. So I'm taking the center, this is Y axis, this is the X axis. So due to symmetric about the Y axis, we can see for the remaining figure, we can see X bar will be 0. Now we have to calculate the Y bar. So first calculate the V1. What is the V1? V1 is the volume for the right circular cylinder. So pi by 4 into, what is diameter? 50. What is the total length? That is 120. So we'll get some value. Now we can calculate the Y1. So what is the Y1? Y1 is the distance of centroid from the x-axis of the cylinder. So for the cylinder, we know at h by 2. So centroid will be here, and h by 2, 120 by total height is 120 divided by 2, it will come 60 mm. Now, total volume we are getting here 5 by 4 into 120, that is 75,000. Okay. Now we can calculate V1, V2. So what is the V2? V2 is the volume of right circular cone. So that is 1 by 3 pi r square. So we have the diameter, so we can write pi by 4 into 30 square. What is the height? 60. So this is the V2, volume of right circular cone. So we can write and we can get this value, that is 4500 pi. Now Y2. What is Y2? Y2 is the distance of centroid from the x-axis of right circular cone. So for the right circular cone, we know if the height is height is h, so centroid, that is G, is lying up to at a distance h by 4 from the base. So base is the x-axis, so h by 4. What is the h here? For the right circular cone, that is 60 mm. So we can write 60 divided by 4, it will come 15 mm. So now we have the V1, V2, Y1, Y2. So we can calculate Y bar, that is V1, Y1 minus V2, Y2 divided by V1 minus V2. So just put the value V1, that is 75,000 pi into Y1, 60 minus V2, 4500 pi into Y2, that is 15 divided by 75,000 pi minus 4500 pi. By solving, you will get some value. So I have calculated some writing directly. So we'll get some value, that is 62.87 mm. Okay. Now, come to this question. This question is very, very important, I would say, because in this case, we have to deduct two, we have to select the two missing area, and then we can calculate that. So see, for this shape, this is the a frustum cone, you can say. So in this case, you can say there is a top diameter is 1 meter and bottom diameter is 2 meter. And there is a central hole also there of 0.5 diameter. So there is a hole. So how we can calculate for the remaining figure? So how we can calculate for center of gravity for this figure? Okay. So now what I'm going to see, what I'm going to do, just see. So first complete this figure by drawing a line. It will go like this. So we can calculate what will be the height. Okay. So draw, I'm taking a axis, that is y axis from the center. This is the y axis and this is the x axis. Right. So see, for I'm taking what will be the total diameter is 2 meters. So radius will be 1 meter. Okay, here diameter is 1 meter, so radius would be 0.5 meter. 0.5 meter, right? Okay. So we have to calculate the other dimension also. See, so you can take this line. So this at the bottom that we have. Okay, so this we have 1 meter here, and at certain height, that is 2 meter height, at a 2 meter height from the bottom, so there is radius is changed, that is 0.5. Okay, so what will be this height? So I am assuming this height is y. Okay, so you can calculate, but due to symmetric triangle, you can write y plus 2 divided by this total height divided by base. So 1 meter is equal to total height of this from the this triangle, like I'm giving a name like OAB and CD. So we can say here triangle O, A, B, and triangle O, C, D are symmetric triangle. Are symmetric triangle, right? So now from the symmetric triangle, we can write y plus 2 total height divided by 1 meter is equal to y divided by 0.5. So from this equation, we can calculate 0.5 y plus 1 is equal to y is equal to 0.5. So from here, y is equal to 2. We'll get y is equal to 2. So means this height also will be 2 meter. Okay, now. See what I'm going to do. So finally, how we'll get this value? So first I am taking this one, that circular cone, a right circular cone with a diameter of 2 meter. This with a diameter of 2 meter is a right circular cone. Then I will deduct from this a top right circular cone with a diameter of 1 meter and height is 2 meter. Here total height is for big side circular cone with a larger diameter, total height is 4 meter, 2 plus 2. So I will deduct this first one, this, then I will deduct this central portion, a hole, a cylindrical. So you can see this is the hole is cylinder. So there I'm going to deduct this one. Okay, so their diameter is given, that is 0.5 meter. Okay, and its height is given, that is 2 meter. You can see in this figure. So finally, we have calculated this as a V1. Then we have deducted this top portion, so that will come under the V2. Then we have deducted the cylindrical portion, that will come under the V3. So finally, by doing this, you will get the x and y bar for the given figure. For the given figure. Are you getting a point? In the previous questions, we are doing this second process, the second procedure also. Like we have calculated, we have taken this total area, then we have taken as a this missing area. But here you are getting this two area are missing, two volume are missing. In terms of volume, we are talking about them. So for this case, you will get this y bar, that will be v1 y1 minus v2 y2 minus v3 y3 divided by v1 minus v2 minus v3. I'll get your point. See this equation here, the v1 minus y1. Here we have deducting v2, so v2 minus y2. Here we are going to deduct v3, so v3 minus y3. Similarly, in the denominator, v1 minus v2 minus v3. Are you getting my point? Okay, so now we are going to calculate v1, v2, v3, y1, y2, y3. See, so what will be the v1? See, v1 is the volume for the right circular cone with a larger diameter. Are you getting my point? So we can write pi by 3 into pi by 4 into d square that is 2 into total height, that is 4 meter. Okay, so right, so we will get some value. What will be the y1? So for we know for this for right circular cone that centroid is h by 2 distance from the base, so it will come h by 4. So total h we have 4 meters, so 4 by 4 it will come 1 meter. So 4 by 4 it will come 1 meter. So I have written here for big pi by 4 into a square into 4, so 1 meter. So here we can write V1, we can write 4 pi by 3 meter cube. 4 pi by 3 meter cube. V1, and Y1 we have 1 meter. Now come to the V2. What is V2? V2 is the volume of right circular cone with a smaller diameter. What is the diameter? Diameter is 1 meter and total height is 2 meter. So we can write 1 by 3 into pi by 4 into d square. D we have 1 meter into height, that is 2 meter. So it will come pi by 6 meter cube. Pi by 6 meter cube. And what will be the y1 here? See, in this case, y1 we have to calculate from the x-axis. Don't confuse here. Okay, so and this centroid will be here. So that is h by 4 from the base. So total h is coming 2 divided by 4. So total we have to calculate for this centroid here. So from here to here, that will become that is y2. So up to here, that is 2 meter is given. So 2 meter plus h by 2, because the distance of centroid from the base of that is h by 4. So h by 4, what is the height of a smaller right circular cone? That is 2 meter, so 2 by 4. So it will come 2.5 meter. That is by 2. I get a point. So whatever we have taken the segments, so that we have to calculate x1, x2, x3 or y1, y2, y3 from the same axis. Okay, that is called axis of difference. Okay, so y2 we have, so y2 we got 2.5 meter. Now let me read something. Now, so V3, what is V3? V3 is the volume of cylinder with a diameter of 0.5 meter. So volume of cylinder we can write pi by 4 into d square, that is 0.5 whole square into total height. So height of cylinder that is given 2 meter. So into 2. So we will get this value, that is you can get pi divided by 4 into 1 by 4 into 2. So you will get pi by 8 meter cube. What will be the y3? What will be the y3? So y3 is the cylinder. Axis is here only, and this centroid will be here for the cylinder. So it will come height by 2. So 2 by 2 it will come 1 meter. So 2 meter divided by 2 meter, it will come 1 meter. I get your point. So what I'm doing, I have selected 3 segments, right? Total right circular cone with the larger diameter. So we have calculated the y1 from the x-axis. Similarly, We have calculated y2 from the x-axis for the second right circular cone with a smaller diameter. Then we have calculated y3 for the cylinder from the y-axis, from the x-axis. Okay, so now we have the y1, v1, y2, v2, y3, v3. Okay, so now we can apply this formula to calculate the and then we can calculate the now just put the value v1. What we got v1? 4 pi by 3. What is y1? So y1 give it 1 meter minus v2. V2 we get 0.5 by 6 into y2, that is 2.5, minus v3, that we have pi by 8 into y3, 1 meter. V3 into y3 divide by v1 minus v2 minus v3. So we have 4 pi by 3 minus pi by 6 minus pi by 8. So finally we will get, I've calculated some writing, we will get 0.76 meter. By power of 0.76 meter. So this was very important, I would say, because we have to deduct 2 volume from the first volume. So then we can get the remaining figure, remaining volumes. Okay. So similarly, you can calculate x bar also in the some other cases. So formula will be v1 x1 minus v2 x2 minus v3 x3 divided by v1 minus v2 minus v3. So by using that, we can calculate also x bar. Okay. These are the references that I used to make this lecture. Thank you. In the next lecture, I will discuss some of the numerical problems from the center of gravity. Okay. And in the coming lecture, I will discuss the moment of inertia. So thank you. What we can do, what you can do by watching this lecture, just use the calculator and all the calculation you have to done by yourself, and then you can check the whether I'm getting the same result or not, same value or not. Okay, so don't sit ideal and whatever I'm writing the value and you're just noting it, just writing in your notebook. So don't do that. Okay, first you calculate by using the calculator, then you can see the value whether you're getting same value or not. Okay, so by doing this, you will learn in a proper way. Okay, thank you.